Hi everyone, welcome to this new session of Thoth demo. Today we are going to talk about a pipeline that we introduced, and this pipeline is going to provide feedbacks when there is a new change basically in the model that needs to be deployed. So imagine that you have your application deployed and some changes appear on the repo. For example, there is a new model that has been trained, or maybe there is a change in your software stack, or some data changed, and therefore a new training pipeline has been run, and again there is a new model that has been created. So all these different scenarios can be taken into account, and what we want to do is basically to provide the feedback as soon as possible to the ML engineer and to the data scientist in order to decide what is the next step. So let me share my presentation. So what we want to do basically to provide feedback for a machine learning model that needs to be deployed. So here we see, for example, what I was talking about. So let's say that the data scientist is working on his project and he finished with this train model, and there is a pipeline that can be retrained if something needs to be changed. For example, there is data drift and a new training needs to be done with new data, or for example, if the new feature needs to be considered. This process is iterative and therefore can be changed different times from the data scientist. But at the end, everything will be stored and in your source of truth, which is in this case the GitHub repo. Then what you do is usually triggering pipelines, and these pipelines would make a release, and this new release can be continuously deployed and monitored, for example, using Argo CD. And these cycles basically continue every time there is a new change. All this process would be automated. But what we want to do is basically provide the feedbacks as soon as possible. So as soon as there is a new train model, as soon as there is a new update from the bot, for example, and the pipeline would give you metrics related to these changes. So why we want to do this feedback? There are several reasons. As we just explained, the application lifecycle is not static. So there are different cycles and continuous training, continuous deployment and monitoring. So all these changes might happen because there is a new release, there is a CVE, there is a new model to be deployed, or dataset has been changed, there is a data drift. So the process is completely dynamic, and we want to basically reduce at the minimum all the processes that needs to be done by the ML engineer and data scientist, and to provide feedbacks immediately. So we want to speed up the process, and we want them to focus exactly on the problem, and the data scientist on the model itself, and the ML engineer on the application status and the quality, and all the metrics that needs to be collected will benefit both, because in this way they can take basic decision on what needs to be done next. And this of course reduce the cost, because they don't need to spend time on things that can be automated, and they can also learn as soon as possible if the new model that needs to be deployed is actually going to perform worse respect to the one that's already deployed, which is very important. What kind of feedback? So we want to provide basically a report. As of now, we thought to have different types of metrics. So the model metrics that comes from the model itself, so the performance, the error rate, the model version, of course, we want to know. Application metrics, so what is the latency of the application for each request, and the platform metric, so how much CPU or memory is consuming. So in this way, basically, we will give them information in order to decide what are the next steps. Feedback, as I said, there are feedback that can benefit different type of personas. So there's the ML engineer or AIDevOps, and they want different type of information related to latency, memory consumption, and CPU. So in this way, they can optimize and adapt the different deployments. And the data scientist that wants to verify that the model that has been trained actually performs also good above a certain threshold also in the deployment. in the production environment, of course. When we want to give this feedback? As soon as possible. So every time there is a new change in your source of truth, which is the GitHub repo, so you open a PR because you're changing the model, you open a PR because you're changing the data set that needs to be used to train the model, or you are changing something in your software stack, or the bot is changing something in your software stack because a CVE appeared for this library. So we need to retrain the model, we need to recreate the image, all these kind of things. So we want to provide this feedback as soon as possible. Just an idea of some of the inputs that are required. And I will show you in a moment whatever is in the repo that needs to be present. So it's an extension of the CI pipeline. So there is a lot of logic that is reused in the tasks in the Tekton pipeline. But in this case, we want to make sure that the project has a deployment. So you have the deployment of a model in your project. So we make sure that there is in the ISOE YAML file a deploy key, either in a specific runtime environment or in a specific overlay. And we want to make sure that your project contains the features, because we base, in this case, the test on the behave library. This is one solution, but can be implemented a different way. This is just a starting point. And we want to basically use this kind of tool because it's a good interface between the test itself and what needs to be done on the back of the test. I will show you what I mean in a moment. And at the end, we came up with this structure of the pipelines. But let me go directly to the demo session so we can explain each of these steps and what is happening. So first of all, I mentioned what the features are. So the behave library allows you to create this kind of tests or features for the test. And you can use natural language to explain what the features look like. So then there is done some process on this text, but the idea is that the feature is, in this case, your test or integration test. So you want to gather metrics on your deployed model. So the scenario wants that I have a data set. So given a data set is available, given a deployment is accessible, so some deployment has been created with your changes, then I want to run the test. In this case, we can use this behave test, but in the future might be that there are different type of tests that can be adopted with these pipelines. Then the metrics that we collected, so as we mentioned, the metrics for the model, for the application, and for the platform, will be basically available to the user. So I open up a request, and what I want to see at the end is a report which tell me what is happening on my deployed model. And if we have a look also what happens on the behave side, that natural language definition is based on the Gherkin language, and it is basically converted to, in this case, to a Python script. So given the dataset is available, we can actually create the test to retrieve the datasets from somewhere. We can make the deployment and make sure that the deployment is accessible. Then we basically run the metrics. The metrics are not specifically fixed on this in this case because it's something that comes from the test. So all these kind of metrics can be adapted depending on what the user want to see, the data scientist and the ML engineer. And then at the end, we basically store all of them in a JSON that can be easily stored on Zeph or in some places that can be retrieved easily and provided to the users. So let's go to the pipeline itself. This is a test that I ran a few minutes ago. The pipeline takes some time, so I will, while we describe each of the steps, I can basically retrigger the pipeline, and then we will see what's happening. So in the meanwhile, I'm working basically on the same PR. Here I made some tests, but basically I open a specific pull request in the project. And what I want to see at the end is these changes. So what happens in the pipeline? So the pipeline itself has several tasks. Each of the tasks has different steps. First of all, the pipeline checks that all the inputs are provided. So the one that we mentioned before, there is a feature, there is a deploy, there is also a runtime environment for the test. If that is the case, that is different from the one that is used for the model application, then you need to provide also that. Otherwise, by default, it considers that the pip file lock and the environment that is provided at the root of the repo, then is the one used also for the test. But might not be the case, so we don't want to stop that. If this is not the case, so if you are using this pipeline and you don't have these features, sorry, these inputs, then basically everything will be clean. So everything will be deleted, this pipeline will stop. Assume that these inputs are done, are correct, then we move to the second task. So the second task basically configure everything that is needed for the pipeline to move forward, and basically checks all the runtime environment, if where are the dependencies, what are the information needed to push the image that is going to be created before deployment. And so these inputs will be later used in a task, which is the build release run. So this task is reused from the ISOE tasks, which are already available. And what it does is basically build the image and then push it to a certain registry, which is stated in AISOE YAML file. Once all of this is ready, basically what happens is that the next task is to customize the deployment. So we want to deploy your image, and we use some customized or default templates, which have a deployment config, route, and a service, because we are deploying in Kubernetes environment. But this is not limited. So those tasks basically can be adapted for different type of deployments. At the end, what we want to have is a way to also compare different type of deployments. So you don't only have already a deployment, but maybe I'm using the Flask application now, but might be better to use Seldon, or for example, to use Cave Serving or TensorRT. So there are different type of deployments that can be used. So we want to provide these feedbacks as soon as possible. So once this customized deployment is done, in this case is a Flask application, so the pipeline is selecting only this type of manifest. Then we want to discover the route. So where is the endpoint where I can basically do my request and collect data. And then there is the actual task that collects everything, and at the end comment in the PR what is happening. This task has several steps. So in this step, as I mentioned, you might have different types of overlay in your project. So one overlay for your inference application, one overlay for your test. So in this case is using a specific overlay, which is called test model. We can find it in the AICOE YAML file of this project. And if my connection goes, yes, you can see that this project is based on overlays. So there are different overlays, and that needs to be considered. And there is also one for inference, and one for the test actually is based on the root directory in this case. So once we have the test, everything is installed using the TimeOS library and the micropipem. Then we run the behave test. As you see, there is a scenario that we mentioned before. So given dataset is available, the deployment is accessible, then I run the test. I run just a subset of the total request to speed up the demo, but at the end, everything will be gathered and stored, all the metrics that have been collected. Then if we move ahead, then we also gather the platform metrics. So in this case, it's something that comes from the pod analysis. These metrics are provided by OpenShift itself, so we can basically gather them. And then we post-process the data. So we have here some intro of what will be the report actually provided to the users. And once everything is completed, then basically the PR updates and comment using directly using the bot in your pull request. And at the end, everything will be cleaned up. So because the other pipeline, I think, is still running, takes some time because it's building, needs to push again, but it's doing all the process, is selecting the correct runtime environment. So everything is controlled. And just to go a little bit faster, I can go directly to the result. So this is basically what I show you in the pipeline a few seconds ago, which was the template. And at the end, you will get all your metrics. So you see the type of test that was used, so the features, you see in which the namespace everything was deployed and where the metrics has been collected. We will add more information here in the future. It's still a work in progress, but the proof of concept is, I would say, almost ready. And then you see that there are all the metrics that might be interesting. For example, the latency, the probability given by each of the requests, each of the request on the predict endpoint, the number of requests, the model version. In this case, we know is coming from a pull request, but in the future, you will be able to compare with the model that are already deployed. And we also want to give information related to the platform itself. So is this model consuming a lot of CPU or memory? So this is also important for the deployment or to adjust and improve everything related to the model itself. And I think that's all. If you have any question, please reach out to us. You can always open issues in our project. And otherwise, thank you very much for listening and see you soon.